Hi, my name is Jon-Andrew Auger-Andrews. I am a sports medicine major at Pepperdine University, and I'm going to teach you how to graph cosine and sine functions. Okay, so when you start looking to graph a y equals sine x function, you have to look for two things. One, you have to look for the amplitude, and you have to find the period. Now to find the period, you look for the first coefficient. So we'll use the basic y equals sine x graph function first. So you look in front, you look for the first coefficient, and there's just a 1. But it's written as sine x, just 1 sine x. So there you go, amplitude equals 1. And then the period, with sine and cosine functions, you need to use the equation 2 pi over b. Now your b is going to be placed right here, in between the sine and the x. So then, since there's no other coefficient that's greater than 1, we just assume that the b is just 1. So in the equation, it would be 2 pi over 1, which then equals 2 pi, which then becomes your period. So with your period, that's how you know how far the entire curvature of the sine cosine graph comes to. So this will just be one period when you have these curves. Let's graph y equals sine x. So with sine graphs, they normally, since this is the basic one, you start off at the origin. So right here. So then, since we know that the amplitude is 1, it's going to go up. So we see that it originates from the origin. So with the sine graph, it goes half of the pi on the x-intercepts. What I mean by that is, since we know that the period is 2 pi, it's going to go intersect right at pi. So this is how it's going to look. It's going to go up all the way to 1, because that's the amplitude, and then it's going to go down from there, intersecting to pi. Now, since the amplitude is both an absolute value, you're going to have 1 and then -1 as your amplitude. It's going to go all the way down. And then it's going to shoot back up at 2 pi. So that is all of this is just one period. Now you see every time that there's a curve, it's going to be bouncing off of half of the period. It's going to be pi over 2, and this is 3 pi over 2. So this is within 0 to 2 pi. That's one period. So then if you want to graph it, you just do the same thing reflected over on the left side. So for example, like pi over 2, putting down values here, pi, 3 pi over 2, down, through pi, all the way up to amplitude 1. It's going to meet up here with 3 pi over 2 as the same thing on this side, and then to 2 pi. So that's within 2 pi and negative 2 pi and 2 pi. That's the interval. So now I'm going to show you how to do transformations and translations with a y equals 2 sine x. So we're strictly going to deal with, as far as translations and transformations and all that generalness goes, we're going to stick with this coefficient in the front. So with a sine graph, normally it's going to look like this. Here's a little mini sine graph for you right here. It's going to look like that. Starts at the origin and whatnot. So with this 2 in front, it makes our amplitude, because we look in front of the sine x for the coefficient to make the height of the amplitude, our amplitude is now going to be 2, which means that it's going to be stretched this way. So now, same thing, the period is going to be 2 pi over b as with the cosine graph, and we know that the period is going to be 1, or no, excuse me, the b, to find the period, the b is going to be 1 because of the x here. It's going to be 2 pi over 1, which makes 2 pi. So we're going to start from the origin, as with a regular sine graph that has no other translations. We're going to start from the origin, and every x-intercept will be a pi, 2 pi. So in the period, it's every half from the origin. So it's going to go here, here. It's going to go all the way up, all the way down, all the way to -2, the 2 pi. And same thing on this side. It's going to hit at this intercept, hit at this intercept, and just like that, like that. So that's how a general sine function with a 2 or another coefficient greater than 1 would look like. It would just stretch it out height-wise. Now we're going to go over here This is a y equals sine 2x. So right from the start, we know that the amplitude is going to be 1 because there's a nothing in front of the sine function to indicate that it's greater than 1. But now, since there's a number in front of the x, that's going to correlate with period. So the period is actually going to be 2 pi over b. So put in the values, it's going to be 2 pi over 2, because it's a 2 here, into this b. Now it's going to be pi. So the period's going to be pi. So as you can see here, I drew from 0 to pi. That's 1 full period. And so, same thing as a normal sine graph. We start from the origin. So it's going to go up. Now, with this one is every half of the pi and pi. So it's going to intercept here and here. And every quarter is going to be the maximum minimum. So it's going to go like this, down, and up. So it actually shrinks it this way. And same thing on this side. It's going to have an intercept at every half of the period. Well, actually, the half of the period, if you think about it. So from the origin, we're going to go right here, all the way down, and that's the minimum, to the pi, negative pi over 2, which is the half, and that's the x-intercept, over with a curve like this, and this is the maximum again, going to 1, and then back down to negative pi. So there you go. That's how you do a y equals sine 2x. All it means is that since you have this in front of the coefficient, it'll be at 2 pi over b. b is going to be, instead of 1, 2 pi over 2 now because of that coefficient. It could be 2 pi over 3, whatever you want it to be. But the big thing is, now that the period is pi, you're going to look at it, and the x-intercept is going to be in the half of every period. So it could be 2 pi, it could be pi, just whatever that half of that is, that's your x-intercept. So now we're going to go to the last one. It's going to be y equals negative sine x. So the only big thing is here, it looks like a regular y equals sine x function, but instead it has this negative in front of it, this negative right here. So it's going to be flipped, or flipped. Either way, it's going to be flipped. So you'll see that same amplitude because there's just a 1. Period's going to be the same as a normal sine function, sine function because there is nothing in front of the x. So instead of the direction going this way, it's actually going to go this way. So let me show you what it looks like. So starting from the origin, it's going to go up, down hitting the x-intercept, through like that. And then it's going to go down, up, into the 2 pi. So there we go. There's the x-intercept right there. And it's going to go right here. So normally, what it would look like with the sine x function, instead of this inverse, I want to clarify this, is that it starts at the origin. So this is a y equals negative sine x line function. This would be a sine of x function. It starts here, hits this. So then it reaches to 2 pi. Now on this side, it's going to go, remember this is an original y equals sine x graph. It's going to go to the maximum, the minimum here, hit this x-intercept at the pi, and go all the way up to the 2 pi. So as you can see, all it is it's flipped. This bolded one is the negative sine function x, which we started with, and this dashed line is a regular y equals sine x function, the basics. So all it is just flipped. And so I hope that this was helpful, and thank you very much, and have a good rest of your day.